Okay, I'm guessing that all of these problems felt pretty basic. They were review problems. They were just kind of us putting everything together from which we've talked about, and I wanted to make sure that you're feeling good about all this stuff, okay? So I'm guessing that you've got all the answers, and you probably got them right. So I'm going to go through these really quickly. If the video needs to be paused at times for you to catch up, that's fine, but I'm just going to try to zip through these. This says we're going to use this idea of x squared plus y squared equals r squared if we're given this secant theta equals -2 and theta terminates in quadrant 2. Okay, so that would mean that x is negative and y is positive. Let's see, secant theta. What is secant theta? Secant theta is r over x, and we're told it's -2. R can never be negative, so it must be the x. And so therefore, from this, we're getting that r is 2 and x is -1. Okay, so then we say, well, we're going to use x squared plus y squared equals r squared. X squared is going to give me 1 plus y squared equals r squared, which is going to give me 4. Subtract the 1, and y squared has to equal 3. So therefore, y equals plus or minus square root of 3. Y is positive in quadrant 2, so we want the positive square root of 3. We should be able to rock and roll through everything and say that we know that sine theta is y over r. So it's going to be square root of 3 over 2. Cosine theta is x over r. So it's going to be -1 over 2. Tangent theta is y over x. So it's going to be square root of 3 over -1 or negative square root of 3. Cotangent theta is going to be x over y. So that's going to be -1 over square root of 3. Secant theta we were given from the very beginning, and that was -2. And cosecant theta is r over y, which is square root of 3. And that's what you should have. Okay, next, it says this time using trig identities. We're not supposed to use x squared plus y squared equals r squared. We're supposed to use trig identities, okay, to find this. We're given that sine theta is equal to -1/4 and that theta terminates in quadrant 4. Quadrant 4, x is positive, but y is negative, and that's why sine theta is negative. Okay, if I'm going to use trig identities and I'm given sine theta, the easiest one to then use is to say that cosine theta is equal to plus or minus square root of 1 minus sine squared theta. And we plug everything in. Now we know it's positive because it's in quadrant 4. So we can kind of forget that part. We say 1 minus, we look at that. -1/4 squared is 1/16. Okay, and so 1 minus 1/16 is 16/16 minus 1/16 is going to give me a square root of 15/16. Okay, so therefore cosine theta is equal to the square root of 15/16 or the square root of 15 over 4. And it is positive. From that point, we should be able to get just about all of them. Sine theta, we were given from the very beginning, is -1/4. Cosine theta is square root of 15 over 4. Tangent theta is always sine theta over cosine theta. So I go, well, that's got to be -1 over square root of 15. Cotangent theta, I flip that and get negative square root of 15. Secant theta, I flip cosine theta and say 4 over square root of 15. And cosecant theta, I flip sine theta and I get -4. Hopefully that's exactly what you had. All right, moving on. Another problem exactly like that, but then they throw us a little bit of a curveball. Instead of giving us sine theta, cosine theta, maybe even tangent theta or secant theta, they give us cosecant theta. So we have to remember that cosecant squared theta is equal to 1 plus cotangent squared theta. That's the identity that would be really helpful for this one, okay? Now, maybe you didn't use that. Maybe you went ahead and said, well, if that's cosecant theta, then I can get sine theta from that, and then I can get cosine theta, and then get everything else. I'm going to show it this way, okay? Excuse me. So for this, what I would have to do is spin this around and say then cotangent squared theta is equal to cosecant squared theta minus 1. I have to subtract that 1, bump it to the other side. So then I would get cotangent squared theta is equal to, so square that value, and I would get 9/4 minus 1. Okay, well, 1 is, of course, 4/4, so that leaves me with 5/4. So then cotangent theta is going to be equal to plus or minus square root of 5/4. This is in quadrant 4, so cotangent is negative in quadrant 4, so this is going to give me negative square root of 5 over 2. Okay, and from that, you should be able to get everything else. I go sine theta, cosine theta. Let's see here. Tangent theta. Cotangent theta. Let's start there. Cotangent theta is negative square root of 5 over 2. So therefore, tangent theta is negative 2 over square root of 5. Cosecant theta is negative 3 halves. So sine theta is negative 2/3. Let's see here. And then same thing as we said before, these always have the exact same denominator. So cosine theta is going to have the denominator of 3. This 2 went there. So this square root of 5 goes here. Okay. And then you flip it for secant theta, and you would get 3 over square root of 5. Now, maybe from the very beginning, what you did is you converted this and said, well, then I know that sine theta is negative 2/3. You would still get all of these same answers, okay? Because you would then say, well, I know that cosine theta is equal to the square root of 1 minus, and you square that, and you would get 4/9. And so that would give you the square root of 5/9, which is the square root of 5 over 3. And that's what we have right here, okay? So either way you go, you would get the same answers. All right, last problem. Review of this idea of this tangent and its connection to the slope. Okay, so we've got a slope of negative 3/4. We're in quadrant 2. So right from the get-go, you should know that tangent theta is negative 3/4. If I'm talking about quadrant 2, that would mean that x is negative and y is, not y, but it's positive. Okay? And so let's think about this. If I've got tangent theta, well, from there I could say, well, just like we did before, we know that secant squared theta is equal to 1 plus tangent squared theta. So secant squared theta is equal to 1 plus square that, and you would get what, 9/16? 1 is 16/16 plus 9/16 would give me 27, sorry. Brain just kind of stopped working there for a second. 27/16, okay? And so therefore, secant theta is going to be the plus or minus square root of 27/16. Now, in quadrant 2, x is negative, secant theta is negative, and so we're going to get negative square root of 27 over 4, which could also simplify down to negative 3 times the square root of 3 over 4, if you wanted to take it all that way. Okay, and then at this point, hopefully you have everything. Tangent theta is negative 3/4. So therefore, cotangent theta is negative 4/3. Secant theta is negative 3 times the square root of 3 over 4. So therefore, cosine theta is negative 4 over 3 times the square root of 3. So therefore, the denominator of sine theta is 3 times the square root of 3, and the numerator is 3. Now, those 3's would cancel out, and so you could simplify that down all the way to 1 over the square root of 3, which would mean that cosecant theta is equal to just square root of 3. All right, and that's what you should have gotten. I hope this works. I hope this makes sense, and I hope you have a great day.